All right, honors chemistry people, we are going to learn how to, as Hank Green says, we're going to learn how to speak chemistry in today and on our next time too. So today we are going to focus on learning how to name and write ionic compound formulas. So today we're going to focus on ionics. So I just want to remind you a little bit what ionics are again. So ionics are compounds that are made out of a metal and a nonmetal, or usually a metal and a polyatomic. So we're going to start using our polyatomic sheets today. So you're going to want to have those ready and handy for you. In fact, I should probably get one of those up on our list. So let me make sure that I get that polyatomic sheet up here so that we can use that, because we're going to want to use that as well. Okay, and we're going to also want just a straight periodic table as well. So we're going to have a whole bunch of different sheets that we're going to be using today. So today we're going to start here on, let's see, what page are we at? We're on page 153. So you're going to want to be on page 153. It's chapter 8, nomenclature. Nomenclature is just a fancy word for saying how you name things. So this is coming from when chemistry was mostly done in German. So to name is, in German, that verb to name is nomen. So nomenclature is how you name things. So we're going to do ionic compounds today, and next time we're going to do covalent compounds and acids. Okay, so just a reminder, compounds are made of two or more elements. So when we are doing compounds, we're going to be naming things that are done with two or more elements. So therefore, it's necessary to know how to combine these elements to make a compound. The chemical formulas give the ratio of atoms of each element in a compound. Okay? So we use that ratio and we put subscripts in to show that ratio. There are three types of compounds that we are going to learn how to write formulas and also learn how to name. Okay? It's very important that you be able to tell which type of compound it is so that you know which type of naming rules to apply. Okay? So we're going to go for ionic compounds. So remember, ionic compounds are where we have ions. So we always have a positive ion, that is usually a metal, joined with a negative ion, which is usually a nonmetal. Or sometimes it's a polyatomic. Okay? So when you see a metal joined to a polyatomic or a metal joined to a nonmetal, or any type of ions going on, you're going to want to apply these rules. Okay? There are four different types of ionic compounds. So there's a metal to a nonmetal, that's A. We have a metallic combined to a polyatomic ion, that's B. We can have a positive polyatomic ion bound to a nonmetal element, and we can have a polyatomic positive and a polyatomic negative. Okay, those are pretty rare, but we do have them. So anytime we have ions, we're going to use this. We're going to look at these four different categories one at a time. So A, we're going to look at a metal bound to a nonmetal. Okay. The first thing we need to know is how to tell if an element is metallic or not. Okay. Some are familiar and obvious, like gold, tin, silver, iron, etc., and nonmetals such as sulfur, carbon, and oxygen. But sometimes they're not so familiar, like lanthanum, niobium, and selenium. So we need a system of identification. On the periodic table at the cover of your text, we actually put in that line between metals and nonmetals. Okay, let's put in that line again really quick so that we can separate that out. So I'm going to move me really quick so that I'm not in the middle. And we are going to put in that metal. And I want this to be relatively thick here. So let's hide this so we have more space. So when we put in the metal line, we always start right under boron, and then we just start making stair steps through that periodic table. Now I'm not going to continue it on because all of these elements down here at the bottom, that bottom row, are synthetic elements. So we're not really going to worry about those so much. So things here to the left are metals. And we have our exception here. Hydrogen is actually a nonmetal. That's our one exception to the rule. And then things over on this right-hand side of this stair-step line that we put in here are nonmetals. Okay, so we're going to use this stair-step line to differentiate between what's going on. Okay, so we are going to take a minute and we're going to look at selenium, palladium, iodine, dysprosium, niobium, and arsenic and determine whether they're metals or nonmetals really quick. So I'll do the first couple ones with you, and then I'm going to let you pause the video and then put things together. Okay, so let's look at selenium. So if I look at selenium, let's change this color really quick to something paler. Selenium's right here. So it is definitely on the nonmetal side. So when I look at selenium, I'm going to mark that as a nonmetal. Okay. If I look at palladium, let's see if we can find palladium. Palladium. That's really not a very familiar one, is it? It's got to be a P something, right? Does anyone see it? You guys see it right here? It is on the metal side. So we're going to mark palladium with metal. Okay, so I want you guys to pause the video, take a minute, look up the rest of these elements, and we'll check in just a minute. Okay? All right, you guys ready to check? All right, so let's look at iodine. Iodine is right here. So it is a non-metal. So we're going to mark iodine with a non-metal. Dysprosium. That's one we're not super familiar with. It's going to start with a D, don't you think? It's right here. And remember, the lanthanides actually fit in right here. So it is on the metal side. So dysprosium is a metal. Niobium. Now, if you're into really good magnets, you know that niobium is where they make the super magnets from. So it is a metal. So niobium is a metal. Oops. Niobium is a metal. And then last but not least, let's look at arsenic. Arsenic is actually a metalloid, but because it is on the right side of that line, for naming purposes, we consider it a non-metal. So for naming purposes, we would consider arsenic a non-metal. But do remember, technically, it's a metalloid. Okay? But for naming, we will call it a non-metal. Okay? So elements that form ionic compounds have a charge. And we talked about how elements create a charge. They either gain electrons or they lose electrons. Remember, the metals tend to lose electrons and have positive charges, and the nonmetals tend to gain electrons and have negative charges. Okay? That attraction between those opposite charges holds those atoms together. We have an electrostatic charge that it's like magnets holding things together. Metals always form a positive charge and nonmetals always form a negative charge. So I want to highlight that because I really want you to remember that. Metals are always positive and nonmetals are always negative. I will be a very, very sad chemistry teacher if you assign a negative charge to a metal and if you assign a positive charge to a nonmetal. That would mean that I didn't do my job right. Okay, so remember, metals are always positive. Remember that nonmetals are always negative. Okay, binary compounds. Now, bi means two, ary means things. So binary compounds are two elements. Okay, these always end with the suffix "ide," I-D-E. Okay, so let's think about how we're going to name this. Write the formula and the name between the elements of sodium and chlorine. Okay, so I'm going to ask you a question in a way that I haven't asked it to you before. I'm going to ask you what the oxidation number is. And the oxidation number is really, what is the charge? What is the charge that sodium would have? And what is the charge that chlorine will have? So let's look at those elements really quick. So if I look at sodium, let's change my color again. If I look at sodium, I'm right here. I'm in that very first column. So hopefully you remember, in that very first column, I'm going to acquire a charge of +1. Okay? So sodium is going to acquire a charge of +1. So we can write it like that with just a plus, or you could write it like this, +1. I'm pretty lazy, so if it's just a 1, I'm just going to put a plus. Okay? What's the oxidation or the charge of chlorine? So let's look at chlorine. Chlorine is right here. It's in our halogens column. So if you remember, our halogens always acquire a charge of -1. So we're going to have a charge of -1 for our chlorine. So when we have chlorine, we could write it like this. It would actually be chloride when it's a negative. So chloride is -1, or I could write it as chloride -1, like that. Okay? So if I want to put these together, I want the charge, the sum of the charge, to be 0. So the sum, and I'm going to use epsilon because epsilon means the sum of. So I want the sum of all charges to equal 0 when I put things together. So how many positive ones with the sodium do I need to match negative ones with chloride? Hopefully you realize that the least common multiple between +1 and -1 is 1. So I need one +1 plus one -1 to equal 0. So when positive and negative charges are brought together, we always want the sum of all charges to be 0. Okay? Always, 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 and forever. Okay? So when I want, why won't this let me write? So positive and negative charges always have to equal 0 when we bring them together. Okay? Since all compounds are neutral. Okay? So when we look at this, if I have sodium +1 and chloride -1, we're going to use the absolute value, 1 and 1. So the least common multiple between 1 and 1 is 1. So I just need 1 of each of these. So I'm going to need 1 sodium and 1 chlorine to equal 0. Positive 1 plus negative 1 equals 0. Okay? So when I write this, I'm going to just have 1 of each. Okay? Notice that when I wrote this, I wrote the positively charged ion first. Okay? It's kind of just normal convention in chemistry. We always write the positive ion first. Okay? This is traditional. So it's kind of like sentence structure. When we look at sentence structure in English, we always put the adjective that's describing the noun before the noun. But if you study other languages usually put the adjective that describes the noun after the noun. So like in Spanish, in English, if I wanted to say the ball is red, I would say I have a red ball, right? I have a red ball. But in Spanish, I wouldn't say that. I say tengo una pelota roja. The red would be behind or in back of the noun. Okay, so it's sentence structure. We always put the positive first. Okay, so to name this compound, remember that the nonmetal is going to end in "ide." We always take the root of the nonmetal and we add on "ide." Okay, so we take the name of the metal, we take that full name, and then we have the root of the nonmetal and we add on "ide." So when I do that, our metal name is sodium. So I would call this sodium. And the root of chlorine is chlor. So I would say chloride. So I'm going to add that suffix on. Okay? So we always have the full metal name. We take the root of the nonmetal and we add on "ide." Okay? So let's write the formula and the name for the compound between barium and iodine. The first thing that we always have to do, very first thing, we have to determine the charge of those ions, okay, so that we can understand the ratio that we need to write them in, okay? So let's look at barium. So barium is right here. It is in our alkali earth metal column, so that will give us a charge of positive 2. So when I look at barium, I'm going to determine that it is going to give us a charge of positive 2. Okay? And then the other thing, I need to look for iodine. So let's look at iodine. So iodine we've already determined is right here. It is in the halogen column, so it will give us a charge of negative 1. So iodine is going to give us a charge of negative 1. So we need to figure out what ratio we need. What is the least common multiple between a 2 and a 1? Hopefully you told me that the least common multiple is 2. Okay, so the next question is, how many positive 2s in the barium do I need to get a charge of positive 2? So to get to a charge of positive 2, I need 1 barium. How many negative 1s do I need to get to a charge of negative 2? Remember, because our least common multiple is 2, so I need negative 2. How many iodines do I need? I need 2. Okay, so I'm going to need 1 barium and 2 iodides. Positive 2 plus 2 negative 1s equals 0. That is my charge ratio here. So I'm going to have 1 barium and 2 iodines. And I'm going to do the 2 iodines with a subscript like this. Now remember, when we name things, we are using the metal name. So the metal is barium. Remember, we always put the positive first. So the metal is going to be barium. And then we have iodine. What's the root of iodine? It's io, right? So we're going to call this iodide. Barium iodide is going to be our name. Okay? Let's do some more. Write the formula between the compound of iron and fluorine. Now, these transition metals get pretty tricky. Iron can be a positive 2 or it can be a positive 3. So, these transition metals, we have to throw in a little something extra so that we understand the charge of what's going on with iron. So let's take iron positive 2 first. Okay? So if I look at iron positive 2, we know that it's positive 2. Let's look at fluorine. Where's fluorine? Fluorine is right here. So it is a negative 1. It's in a halogen. Fluorine is a negative 1. So we've got our charges. Next, we need to think of our least common multiple. So our least common multiple of 2 and 1 is 2. So to get to a positive charge of 2, I need 1 iron. And to get to a negative charge of 2, I need 2 fluorines. Okay, so I need 1 iron and 2 fluorines. So the formula is going to be like this, FeF2. Now, let's look at iron positive 3. Let's just give this a go before we name them. So iron is a positive 3, and we know that fluorine is a negative 1. So what's our least common multiple between 3 and 1? Our least common multiple between 3 and 1 is 3. So how many irons do I need to get a charge of positive 3? I need 1 of them. And how many fluorines do I need to have a charge of negative 3? 3 times negative 1 will give me negative 3. So I need 3 fluorines. So our formula here is going to be 1 iron and 3 fluorines. Now, they can't both be iron fluoride. They're different. One has 2 fluorides and one has 3 fluorides. So how do we differentiate them? The way we differentiate them is we throw in Roman numerals. Okay, so hopefully you know your Roman numerals. You need to know them up to about 6. Okay, so I'm just going to do really quick, just a little reprieve. So Roman numeral for 1 is just I, capital I. Roman numeral 2 is just II. Sometimes people will put like tops on these, like that. You can do that. Roman numeral 3 is III. 4, it's IV. Okay. 5 is V, and 6 is VI. Okay. So we're going to use Roman numerals to differentiate these. So because this iron in this first one is a +2, we're going to use the Roman numeral 2 to show us that it is a positive 2. So we're going to name this like this. We're going to call this iron 2. We're going to use the Roman numeral 2 here. Now, some people will not put the parentheses in. Some people will. It's more correct to put the parentheses in. So remember, that 2 tells me the charge of that iron being positive 2. Okay? So iron 2 and then fluorine. So fluoride. Okay? Now for this next one, our iron is charged positive 3. So we are going to grab the Roman numeral 3 to designate that charge of positive 3. So we're going to call this iron 3 fluoride. Okay? Now remember, these Roman numerals come from the charge that the metal acquires. And you're going to need to put in Roman numerals for the transition metals. Okay? So let's just go back through. Well, actually, let's do that in a minute. So let's name this compound. We've got copper and we've got sulfur. Now, the thing is, copper right here, copper is a transition metal. It can be either a +1 or a +2. We don't know what it really is. So what we need to do is we need to see what it is bound to and to then determine the charge from that. Okay, so let's look at what it's bound to. So we see this is bound to sulfur. So let's look at sulfur. So if I look at sulfur, sulfur's right here. It is in our -2 charge area. So sulfur has a -2 charge. So remember, this whole thing has to add up to 0. So what does the copper have to be? So something plus -2 equals 0. What is that something? What do you think? Hopefully you said it's got to be a +2. +2 plus -2 equals 0. So we know that the copper is a +2 here. Now we're going to have to put Roman numerals in here to designate that copper is a +2 and not a +1. So we're going to call this copper 2. And then sulfur, the root of sulfur is sulf, so sulfide. Okay? All right. So I want you to spend a minute and see if you can name this next one. Okay? We have strontium and we have selenium. Now I'm going to warn you guys really quickly that this is kind of a trick question. Okay? So let's look at this one really quick. Take a minute. Okay, now strontium. Let's look at where strontium is. Strontium's right here. Okay, we know that that is always going to be a +2 charge because it's an alkaline earth metal. So because we know it's always going to be a +2 charge, do we need to put in Roman numerals? No, we do not. We only put Roman numerals in for the transition metals. Okay, so let's look at how we are going to name this. So we know that the strontium is a +2, and we know that selenium, let's look at selenium. Selenium is a -2, it's right here. So we have our ratio of 1:1. And because we do not need Roman numerals, we're going to call this strontium selenide. Okay? Now you don't have to capitalize things like I do. I'm just kind of bad. I put capital things where I should. We could also write it just strontium selenide. Oops, I can't spell. Selenide. Okay? So the next question then becomes, since I kind of threw you under the bus, we don't really need Roman numerals all the time. We only need Roman numerals when we have a transition metal. Okay? So we need Roman numerals when we have transition metals. And remember, transition metals are pretty much the D block. So let's get a new periodic table. So let's close this out. Let's not save it because I don't want all that marking that we've done on it. And let's reopen it fresh. Okay. So let's do some fresh marking on this. Okay. So let's put in our metal line once again. So we want to keep this metal line going. Okay. No. Okay, so let's put in our charges right here. So the alkali metals are going to be +1. Hydrogen, you can also almost guarantee it's going to be +1. Not always, but almost always. Alkaline earth is going to be +2. Okay, let's start highlighting these. The halogens, these guys are going to be -1. The oxygen column is going to be -2, but remember, you can't go all the way down on this one. So we only really go to selenium here. So you're going to be -2. And then this next column, going to be -3. Let's get some colors on this other side. So these guys are going to be +1. Color these in. These guys, the alkali earth metals, these guys are going to be +2. Okay, transition block. Let's do yet another color for transition block. Let's do orange. Okay. Now the transition block, these guys all need Roman numerals, and I'm going to add in the F block as well. They all need Roman numerals. I'm going to skip out on the made up elements. So these guys all need Roman numerals, the ones in orange. Okay. Now, there are some that don't. So let's highlight the ones that don't really quickly. Now, the ones that don't are these. Aluminum is always a +3. Okay. Zinc is always a +2. Cadmium is always a +2. And silver is always a +1. Okay. So those 4 right there are the exceptions to the transition metal block. Everything else in the transition metal block that I have outlined in orange need to have Roman numerals. Okay. So let's do some more practice. So the exceptions here for the transition metals are silver. Silver is always a +1. Zinc's always a +2. Cadmium is always a +2. And aluminum is always a +3. Okay, so we just put those on the periodic table. So if you want more periodic tables, print one out, color it up, or I have ones that I can hand you out here as well if you want to come in. All right, so before we go any further, here are some more handy hints. Okay, so perhaps you've already discovered on your own that all elements except for hydrogen in group 1 in the periodic table have a charge of +1 and never anything else. So we already put that on the periodic table. Now hydrogen by and large will be +1 like 95% of the time. So that's why I included it. Okay. All elements in group 2 have a charge of +2. So yep, the alkali earth, +2. That will always be true. Okay, all elements in group 17, i.e. the halogens, are always going to have a charge of -1. That's why we've marked the halogens with -1. Okay, and all nonmetal groups in group 16 have a charge of -2 and nothing else. So that's why we have marked oxygen, sulfur, and selenium with -2. They will always be -2 and nothing else. Okay, and all other metals have more than one charge, and that charge needs to be given in the name by using Roman numerals. Okay, and we put those, we outlined all the transition metals in orange. So those all need to have Roman numerals with the exceptions of aluminum, zinc, silver, and cadmium. Okay, so aluminum's always +3, zinc and cadmium are always +2, and silver is always +1. Okay, so let's go on to metallic elements combined now with negative polyatomic elements, a radical. Polyatomic ions. Now, poly in Greek means many, right? So, many. And then atomic means atoms. So we have an ion made up of many atoms, and we did Lewis structures with some of them. Remember, we had to add or subtract electrons for those. So we are going to introduce those polyatomic radicals or ions to you. Now, they're on the back side of your periodic table that's in the very front of your list or the very front of your workbook. So if you go to the front of your workbook, you're going to see this periodic table. And then on the back side of that periodic table, we're going to have this polyatomic sheet. Now, these are the ones that you are going to be familiar with for this class. And no, I do not expect you to memorize them. You will probably write enough formulas that you will memorize a good share of these by the time we're done with this class and writing formulas. So let's go over them really quickly, just give you an introduction to them. Okay, so the first one is CH3COO, and it's got a charge of -1. It's called acetate, and there are two ways to write it, okay? So you can write it C2H3O2, -1. This is the inorganic chemistry way. This is the way that most chemists would write it. Or there's this way, which is what I call the organic chemistry way of writing it. And because I am a biochemist and we do things the organic chemistry way, that's the way I'm most familiar with, but either way is really correct, okay? Then we have ammonium. Ammonium is our one and only positive ion. It's NH4 +1. Then we have arsenate, benzoate, bicarbonate, bromate, carbonate, chlorate, chlorite. Notice chlorate and chlorite are only different, chlorate and chlorite are only different by one oxygen. So 1's an 8. 8 means 1 more oxygen. 8 is 1 less. You're really going to have to be careful on spelling and pronunciation here, okay? We have citrate, cyanide, dichromate, hydroxide, hypochlorite. Notice that is a group in the chlorites too. Iodate, phosphite, nitrate, and nitrite. This also. Oxalate, perchlorate, periodate, permanganate, phosphate, silicate, sulfate, and sulfite. Here we have another 8 and an ite. Thiosulfate and tartrate. Now, we are going to always give you this sheet to use during exams and quizzes, so don't worry about memorizing it, okay? So just so that you know how to use these, all right? So let's go on. So we're going to write the formula for chromium 3 nitrite. Now we have nitrite. The one thing we've got to do is look up nitrite. So if we look up on our periodic or on our polyatomic, nitrite is right here. It's NO2 negative 1. Okay? So we've got NO2 and a negative 1. Now this front part, we've got chromium 3. That 3 tells me that the chromium is charged positively 3. So I know that I've got chromium with a positive 3. Now the next thing I've got to do is I've got to figure out my ratio, okay? So if I have a positive 3 and a negative 1, my least common multiple between 3 and 1 is 3. So how many chromiums do I need to have a positive 3 charge? I need 1 chromium, right? How many negative ones do I need to get a negative 3? I'm going to need 3 of these, right? So I'm going to need 1 chrome, and I'm going to need 3. Now, how do I make 3 when I have a huge group like this? I use parentheses just like I do in math. So if I want to multiply a group, like I want to multiply a group in math, I use parentheses. So I'm going to put parentheses, and I'm going to put the nitrite ion, and I'm going to close the parentheses, and I put my multiplier as another subscript there. So that 3 multiplies everything in that parentheses. So that means that I have 1 chrome. It means I have 3 times 1 for the nitrogen. This will give me 3 nitrogens, and 2 times 3, it will give me 6 oxygens. Okay, so that 3 multiplies everything in that parenthesis. Okay, so chromium 3 nitrite, this would be our formula right here. Okay, name the compound. We have rhenium, and we have, what is SO4? Rhenium's a transition metal too. Okay, so I'm going to have to look at SO4 and look at the charge that SO4 has to determine the charge of that rhenium. So let's look for SO4. So if I look here, SO4 is sulfate, and it's a negative 2. So this is sulfate, and it's SO4 negative 2. And I've got 2 of them. So that gives me a grand total of negative 4 for my negatives. So, we still need to figure this out. 0 equals something plus a negative 4. What is that something? Hopefully you said that something has to be a positive 4. So that means that the rhenium here is a positive 4. Okay? So we're going to call this rhenium 4 sulfate. Okay? Rhenium. And we're going to put the Roman numeral 4 for its charge. Remember, that is the charge of the rhenium. Rhenium 4. And that polyatomic was called sulfate. and we just use the polyatomic name. So when we do this, we are going to just have the polyatomic name. Okay, this next one, write the formula for silver permanganate. So silver, if we look at our chart, silver was always a positive 1. So we know silver is a positive 1. So we can start off with silver being a positive 1. Let's look at permanganate. That's got to be one of our polyatomics. So permanganate, do you find it? They're alphabetical. Yeah, permanganate. It's MnO4, also negative 1. Okay, so MnO4, negative 1. So silver is a positive 1, permanganate is a negative 1, so we need to find our least common multiple. It's 1. So I need 1 silver and I need 1 permanganate. So we are going to write 1 silver and 1 permanganate. So that is the formula for silver permanganate. Okay, do you want to try this one on your own? Give it a go. Okay, so hopefully you've determined that this is cobalt. Cobalt is a transition metal, so I don't know what charge it is, so I'm going to have to look at what it's bound to. So let's look at what it's bound to here. So OH. Do you guys see it? OH. Hydroxide. Hydroxide is a negative 1 charge. So this is hydroxide. And it's a negative 1. I've got 2 of them. So negative 1 times 2 gives me a negative 2. So if I have a negative 2, what does the positive side have to be for this to add up to 0? Hopefully you said a positive 2. So we know the charge on cobalt is going to be a positive 2. So I'm going to designate that with a Roman numeral. Cobalt 2. And then we're going to use the full name of the polyatomic, hydroxide. Okay? Write a formula for ammonium bromide. Now, ammonium is one of our one and only positive ion that we're going to use this year. So ammonium is right here. It's NH4 positive 1. NH4 positive 1. All right, and then we have bromide. What does bromide come from? Does it sound like bromine? It is. So let's look at bromine. Bromine is right here. So it is in our negative 1 column. Bromine is in our negative 1 column. So we've got a positive 1 and a negative 1. What ratio do we need to have them add up to 0? Hopefully you said 1 of each. 1 plus negative 1 equals 0. So when I write the formula, remember, I always put the positive ion first. Okay? Remember, the positive ion is always first. Okay, so that would be ammonium bromide. All right, so let's name the compound NH42CO3. This is where we have 2 polyatomics together. So hopefully you realize that the NH4 is the same thing that we have here. So we're going to start with the ammonium. And then we need to look up the compound CO3. What is the ion CO3? Do you guys see it? It's carbonate. And when we have 2 polyatomics, we put both of the names together. So we're just going to put both of the polyatomic names together. So ammonium carbonate. So when you have a polyatomic with a polyatomic, you always put the positive polyatomic first and the negative polyatomic second, and you use both polyatomic names. Okay? Example 12. Ooh, we have cerium. Cerium is definitely a transition metal. So we're going to have to look at what cerium is bound to. So C4H4O6. Let's look at C4O4O6. So C4H4O6, it's tartrate, and it's a -2. So we're going to use tartrate. And it's a -2. We've got 3 of them. So -2 times 3 gives me a -6, right? That gives me a -6. Okay, so that means the positives here have to add up to +6. But I've got 2 of them. So +6 divided by 2 will give me a +3. So that means that each of the ceriums are +3. Okay? So I'm going to put the cerium, and I'm going to put the charge here of +3 when it will let me. Okay, cerium 3 tartrate. Oh my. Hey, how'd you guys do? All right, so let's do some more. Now, these are some that I want you to write formulas for. So take a minute, see if you can write formulas, and we'll check in just a minute. Okay, so A, we have copper 1 sulfite. So that means that this copper is a +1. So let's look up sulfite. So sulfite, sulfite is SO3 -2. So SO3 -2. So what's my least common multiple between 1, +1, and -2? Hopefully you guys said 2. So how many coppers am I going to need? I'm going to need 2 coppers, and I'm going to need 1 sulfite. So I will write this Cu2SO3 for copper 1 sulfite. How'd you do on that one? Okay, tin 4. So we know that tin here is a +4. Fluoride, we are using fluorine. So if I look at my periodic table, fluorine is right here. It is a -1. So here we go. Fluorine's a -1. So what's my least common multiple between 4 and 1? Hopefully you said 4, right? My least common multiple is 4. Okay, so that means I need 1 tin to get to a +4, and I'm going to need 4 fluorines to get to a -4. So tin 4 fluoride would be SnF4. Okay, gold. Gold is a +3 here. And cyanide. Cyanide is one of our polyatomics. So let's look up cyanide. Cyanide, -1. Cn -1. Okay, so my least common multiple between 3 and 1 is a 3. Okay, so that means I'm going to need 1 gold. It means I'm going to need 3 cyanides. So 1 gold and 3 cyanides. Now remember, when I need to multiply a group, I have to use parentheses. So AU parentheses CN close parentheses 3. Okay, how'd you do on that one? All right, lead 2. So lead is a positive 2 charge, and sulfide. Sulfide is not one of our polyatomics. Sulfide comes from sulfur. So let's look at sulfur. Sulfur is a negative 2. Okay, so my least common multiple between 2 and 2 is 2. So I need 1 lead to get to positive 2, and I need 1 sulfur to get to negative 2. So PbS. Okay, how'd you do on that section? Okay, now we're going to flip it. I've got compounds here, and I want you to see if you can name them. Okay, so take a minute, pause the video, and we'll check in just a few. Okay, you ready to check? All right, so iron here is one of our polyatomic, or it's not a polyatomic, but it is one that it's a transition metal. So we don't know what it's charged, so we need to look at what it's bound to. So it's bound to NO3. So let's look at NO3. So if I look at NO3, I've got nitrate, and it's a negative 1. Okay, so this is a negative 1, and it's nitrate. So if I have 3 negative 1s, that gives me a negative 3 charge. So what plus negative 3 equals 0? Hopefully you said positive 3. So that means that iron is positive 3. So I'm going to have to designate that with Roman numerals. So I have iron 3 nitrate. How'd you do on that one? Okay, strontium. If we look at strontium, strontium's right here. It is not a transition metal, so I do not need Roman numerals because it's always going to be a positive 2, regardless of what I do. So I just need to name it. Strontium hydroxide. Remember, only the transition metals need Roman numerals. Okay? All right, cobalt. Cobalt is a transition metal, right? Cobalt's right here. It is a transition metal, so we've got to figure out its charge by what it's bound to. It's bound to chlorine. So let's look at chlorine. Chlorine is right here. It's a negative 1. So because chlorine is a negative 1, and I've got 2 of them, so negative 1 times 2 gives me negative 2. Negative 2 plus positive 2 equals 0. So that cobalt is positive 2. So cobalt 2 chloride. Remember, we have to add that "ide" when we have a non-polyatomic. When we have a non-metal, we take the root and we add "ide." Okay. Mg, magnesium, is not a transition metal. So I don't need Roman numerals. I can just say magnesium. And then magnesium, what's BrO3? Let's look at our polyatomics. BrO3, it's bromate. So this is going to be magnesium bromate. Now, no, you don't need to capitalize the bromate. I just am in the habit of capitalizing both. All right, sodium. Let's see. Sodium is in our first column. So we don't need Roman numerals. Oops, that did not circle. And then we have bromine right here, which is in our negative 1 column. Now remember, when we do a nonmetal, we use the root. So the root of bromine is bro. So bromide. Remember, when we have a nonmetal, we have to add in IDE. Okay, Lead. Lead is a polyatomic. So we've got to figure out what this lead is bound to. It's bound to CH3COO. Let's find CH3COO. It's right up here. It's acetate, and it's a -1. So this is acetate, and it's a -1. We've got 2 of them. So times 2 gives us a -2. So what plus -2 is a 0? +2, right? So this lead is a +2. So lead 2 acetate. All right. So you will have a bunch of naming for your homework, and good luck. If you have any questions, please give me an email or call me or whatever, or talk to me in class. And we will talk about properties of ionic compounds, and we will learn how to name covalent compounds and acids next time. All right. Have a great day. Bye.